All right, let's go. We're live. We're rolling. Lights are on. They're bright. Everything's hot. I gotta say, it's gonna be a bit warm today because when it gets cold like this, here in Texas, we gotta turn the heater on, and then the office, while technically the vent's closed, it just puts a ton of heat in here. But to keep the rest of the house comfortable, this room always heats up really hot. So if I start sweating spontaneously, that's why. It's just hot, the heater's on, and yeah, this is just one of those, this is a fairly old house, right? So it's just one of those really poor designs back when, things were just good enough. I will say, so that duct job I'm doing for a friend, I did have to delay it. And what I ended up doing is I ended up going to his house and just doing a complete redesign. What's hilarious to me, it's just so crazy. So he's got like 2,200, 2,300 square foot house, something like that. And he's had multiple major companies in the area come and give him like quotes and talk to him about potentially like upsizing the unit, expanding. He did an add-on, so it added like, what was it, like 400 square feet or something. I don't know. It was 22 by 18 space. So he converted what was the garage into an additional like living type room. Anyway. So yeah, he's got a pretty large layout, but with the way the house is oriented, he's got a 4-ton system. Looking at how the house was, my instincts when I was going over is like, I'm actually kind of nervous that 4 tons may be a bit much for this. I'm hoping we can actually, like, we're not still oversized with doing an actual load calculation. Because the original duct job was quite literally, they just went in, threw different boots of relatively okay, it should be this or that size, and just kind of slap duct in. I mean, I could show you, well, out of privacy I won't, but it's the classic spiderweb duct, right? Every single trunk has has its own independent run coming off of the plenum, which is just nuts, right? That's not how you do it. And what was hilarious to me was the room that they did as the add-on ended up having 2 6-inch boots put in there. And instead of using a Y to like run a single run and then split off between the 2 6s, they literally got one of those, and this was something, Home Depot is one of the only places I know that carries these. They got the, it's literally a T. It's not even a Y. It's a T fitting with a 6x6x6 T. And so they came off of this extended plenum, which wasn't even necessary for the way this house is designed. But they put this extended plenum in, and then turn around and ran this 6-inch run to these 2 6-inch drops, but used a T on the first drop of the run and then let it just feed to the second. Now the problem is, the way they built this plenum, they literally they come in and then go immediately straight out the other side with another primary drop for the kitchen. So what actually happens there, majority of the air to that entire side of the house, which has very poor airflow at the moment, just shoots straight through into the kitchen, and basically the dining and the add-on get next to no air at all. And that's because they're coming off on the side of the plenum, while the kitchen is coming off on the end, right in alignment with the inlet, the feed duct coming in. It's just, anyway, I'm hoping to do that with them, later this week, probably this weekend. I'm going to get with them. Depends if we can get all the material together. But yeah, it's just like when I saw that T fitting instead of a Y, Like, I already knew it was a rough job, but when I saw that, it's just so disappointing. Realistically, though, the people who were doing that work, I don't think are actually industry trained. I think it was just something that the remodel crew just kind of slapped in there without really knowing what the heck they were doing. So in fairness, I don't think it was a actual HVAC tech who put that in. I think it was just some random construction dude who just, well, this works, and slapped it in. Because of course it works just like, water flow and, water pipes, and you just put a T into a water pipe and it gives you water. What more do you want? I can't even say it with a straight face. I'm sorry. Anyway, okay. We do need to follow up on a question from last week that I didn't give a sufficient answer for. I was mostly okay going back, and I spent this week really kind of diving into the question and getting myself familiar properly, and so we're going to get into this here. But there are some things where I definitely learned some stuff, right? How they're using the float and the bubbler, not at all what I actually thought it was, or what I was mostly just kind of guessing of, okay, well, I see this design, so I'm assuming maybe it's doing this. No, that's not at all what it's doing. It's actually doing something quite different than what I thought it would be, and that's okay. That's why we research, and we come back, we reconvene, and we hit it. Let's dive in. Let's go ahead. Let's dive back into that question. We'll review that, and then we'll start rolling through the additional questions. Feel free to start getting them in, and keep in mind throughout this stream and this process, absolutely, there's no limitations necessarily on your questions. There's no skill level expectation. I don't really care what your skill level is. I don't care how dumb or how many times I hear or I see people post and they're like, well, this is kind of off topic, but no, none of those things are off topic. This Q&A session is not, like, sure, we're talking about chiller systems, but understand, like, chiller systems encompasses the chiller itself, the pumps, the hydronics, the plant as a whole, the building as a whole, the processing load. Like, there's a lot that goes into a chiller system or a chiller plant, and that is kind of the core focus. But even if you've got some basic RTU questions, I'm not opposed to answering that stuff, or just going back into some very basics of if you need help clarifying something like saturation or anything of that, like just even some basic stuff. That is the goal of this, is how often do you get to sit across from somebody and just have genuine open dialogue questions that you don't have to necessarily feel nervous about. Like, you can have a lot of what do they call it, anonymity, I think that's the right word. You can have a lot of that with a stream like this, because like nobody, how many people, now some of you are actually known here, but for a lot of you, especially if you're newer to this, not everybody knows who you are outside of this stream. So you can really ask some of those questions. It might be really hard to ask anywhere else, and that's okay. You don't have to be at a certain level to qualify to ask a question here, or the question doesn't have to meet any criteria. I just asked that it be in the HVAC realm. That's my core ask. Let's just keep it within HVAC. And like, I specialize in chiller systems. I also specialize in other stuff, like VRFs is one of my specialties. So I can get into other stuff as well. I'm putting that out there because it comes up so frequently, and I see it in the chat feed many times where it seems like you're nervous to ask that question, and whether or not it's relevant. It is, absolutely. Okay, let's roll into this. Can you explain the float valve operation on a Carrier 19XR? So this is a follow-up to last week's question, and we're going to kind of cover this from the get-go. I do want to discuss this format here in just a minute, but let me zoom in a bit here So we can get a little closer. Let's see how this is going to work. So this is the refrigeration circuit for a 2-stage. Now bear in mind that there's 2 versions of this chiller. This is a 19XR by Carrier. So the single stage, which I just decided to pull out this book, but the single stage does not have this economizer setup. The single stage comes straight out of the condenser into the evaporator, which goes back into how a flash tank economizer works, which is what this is. This is a flash tank style economizer with this particular machine. This is why it's important to learn these fundamentals, and I can dive into flash tanks separately in a different question. If you need that, feel free to post that in the comments. But skimming over that, just understand 2-stage machine, okay? But Carrier uses the same type of metering valve for the 2-stage or the single-stage compressor. The difference is whether or not it has the economizer. So let's get into our refrigeration circuit here. We're just doing a quick recap of how the circuit works in this machine, and then I'll roll into deeper on what that float valve is doing. So we come out of our discharge, coming into the top of our condenser barrel. This then pushes that discharge gas down into the barrel itself. Condensing happens, right? We have condenser water tubes in here that we're flowing across, and then that removes our heat. We start to build a column of liquid here in the bottom. Now there is another chamber inside of this machine. So this second chamber, they call it the flask. What is that? F-L-A-S-C, flask chamber. So the flask chamber is it's not exactly an economizer, but it's kind of like one. I wouldn't go as far to say that it's as a full-blown like flash tank economizer, but at the same time you could kind of think of it like one, really, because of how it's functioning. So let me explain what it does here. So on the bottom of this chamber inside of the condenser, there's these orifice plates. Okay, they're just fixed orifices. They're not variable of any kind. And as the liquid level builds in the condenser, we get up to these plates and we start to flash coming into this chamber. Now in this chamber we have a lower pressure zone. Okay, you could call it a type of medium pressure. So in this particular case, this would be our medium high pressure. Now we start blending into like a CVH world here, where we have medium high and medium low pressure, and then we have our low and high. Anyway, so we have kind of a medium high pressure with this economizer. If it didn't have the economizer, we would just call this our medium pressure zone. Now medium pressure could mean a lot of things. The core of how to define a medium pressure is it is in between our high and low pressure, but it's still an intentional part of the operating circuit. You know, with a normal refrigerant circuit, we're just going from high pressure to low pressure through the metering valve, and that's it. But when we start dealing with tanks like this, or these types of economizing chambers, that's when we start dealing with intentional medium pressures, where we're not going from one extreme to the other immediately. We're actually entering into this mid zone, but it's still part of the design. It's not on accident. So we flash off, we enter into this flash chamber called a flask chamber by Carrier. So the liquid refrigerant entering this chamber stays at the bottom, and it drains into the metering valve drip leg, or the float valve chamber would be another way to save that. So, and then the vapors that flash out of that liquid refrigerant start to collect up here in the top of the chamber. Now this chamber does have condenser tubes running through it. So not only is the outside of this chamber condensing that liquid refrigerant down from a high pressure discharge gas to a high pressure liquid, but then we're also taking this medium pressure. We have a medium pressure liquid draining down, and we have a medium pressure gas inside of this chamber at the top. Those condenser tubes are then cooling that medium pressure down and allowing it to condense so that it drains into the float valve chamber as well. So you have both processes happening there simultaneously. It's a lot. So there's a lot happening. Ultimately, as it drains down, we process through our float valve, and I'll go deeper into the float valve in just a minute. But we flow through the float valve. This particular one comes into our flash tank economizer. So this would be our second stage economizer. That would be a realistic way to look at this, in my opinion. Some people may argue that. My opinion is I would look at this as a second stage economizer, this being first stage, this being second stage. And this would be your first stage flash, second stage flash, final metering device going into the evaporator. That's how I would personally lay this out, and looking at just from a design principles, right? So let's take everything back to design principles themselves. What is the core root? And then we'll build from there. All right. So this particular case, so this liquid vapor mixture enters the economizer. The flash gas coming off of this metering device, because we then go from medium high pressure to medium low pressure, not low pressure, medium low. The second stage impeller then draws off that vapor refrigerant that gets collected at the top of this economizer tank, and then there's another float valve at the bottom of this economizer that then is metering flow into the evaporator itself. And then we can have other stuff in here, hot gas bypass circuits, yada yada yada. But that is the function of this. Like I said, if this wasn't a two-stage compressor, it was a single stage, then we wouldn't have any of this, and we would just come straight out of the float valve, and then directly into our evaporator and go from high pressure to medium pressure to low pressure. But in this case, with the economizer two-stage, we go from high pressure to medium high to medium low to then low pressure. Then we draw back into the compressor, and then we compress that up back to a high pressure, and the cycle repeats. Okay, that is the core function. There's no other heat exchange happening inside of this side of the economizer. And in Carrier's literature, they're not going to call references as an economizer, even though if you read the description, they're describing what is a flash tank economizer, in my opinion. They're not going to call it that. They'll call it the flask chamber, and fair enough, it's not the traditional economizer design. And then they go into what they actually call the economizer. That's how they will reference this. Even in the other style with just a single stage compressor, they will still reference this as the flask chamber, not the economizer. So just understand that if you're reading this material or you're trying to research this material on your own, these definitions matter, and it can be the difference of finding what you need to know so you understand, and not finding it. If you don't have the proper terminology and understand what's happening, you're not going to be able to reference this material correctly, and that's where you're going to struggle, right? That's why I harp on this so heavily. Okay, so let's go back over to the whiteboard, into the actual float valve. Let me get my camera. Okay, so coming out of the bottom of the condenser, we have this chamber that dips down, and this is our float valve chamber. So this valve comes up. It's got perforations right here, and there is a float assembly that kind of does this maneuver. So this sits down inside, and this is this kind of bulb sitting on top of the slide mechanism. Okay, this bulb is what is sliding up and down to meter the flow through these slits in this in the outlet port of the metering valve itself. Now there is a component called the bubbler tube. I'm going to draw this in red intentionally. So the bubbler tube comes up right here, and this comes back to the discharge, or top of the condenser, somewhere in there. Okay, this is discharge gas. So what's happening is this up here would be our flask chamber. Okay, so bear that in mind. We'll go green. So this is our flask chamber. And we've got liquid refrigerant that is draining into our float valve chamber itself. And we've got our fixed orifice plates over here metering that liquid refrigerant coming in, and then the vapors rise to the top, and we've got a column of liquid refrigerant collecting in the bottom of this chamber as it then gets metered and flows out to either the economizer or the evaporator. Just kind of depends on the style of machine. So I talked about this a lot in the last stream, but something to understand with machines like this: as load increases and decreases on the machine, the compressor moves more CFM and stages up and down, if you will. That affects how much liquid level ends up getting stacked and moving through the machine, or how much total refrigerant is actually cycling at a given time, right? So the higher the machine loads up and stages, the more refrigerant it's physically moving, which does result in higher levels here. So as we have more load on the machine, more liquid is getting into here. This valve opens up because of higher liquid levels, because we're moving more refrigerant in total, which then allows us to feed more into the evaporator, which is getting more suction pulled on it because of the higher load. It is a very special balancing act that's happening. And then as load is reduced and the machine unloads, we don't move as much volume of refrigerant. As that volume reduces, the total liquid level in that condenser will begin to drop some. As that liquid level drops, we will have the float mechanism lower a bit, which pinches off or reduces total flow to the evaporator, or to the economizer, whatever the case may be. And that is the core principle of how this is modulating to control flow. Now, this bubbler tube, I need to label that. So, bubbler tube, and then this is the float valve chamber. This bubbler tube, its job is to take some discharge gas, and it actually is filling the underside of that of this bowl, this upside down bowl, with vapor. That is its core function. So it's a very small tube. It's not trying to hot gas bypass, which is one of the concerns that we have with a design like this, is not letting this tube become a hot gas bypass, but it is allowing just enough vapor into this bulb that it then basically the vapor gets vapor trapped. You know, when you take a cup of water, or how about this? No, when you take a cup and you have a bowl of water, and then you put the cup upside down into that bowl and kind of make an air seal at that point, well, then you can push that cup underneath the water level. Water doesn't necessarily go into the cup. The air creates an airlock and it holds it, but the cup has buoyancy, right? So that buoyancy makes that cup want to push back and push up out of the water because it has air trapped inside. That is the exact same principle that this type of bowl is using with floating on that liquid refrigerant. Because this bowl is full of vapor refrigerant, it's intentionally, or it's going to have a lighter buoyancy than the liquid refrigerant does, and that's going to allow it to try to want to float up and down on that liquid level as it's modulating through. This is where having a correct refrigerant charge in these machines is very critical, because it's going to have a heavy impact on this metering valve's ability to control flow through it, because it's engineered so that it's responding to how much liquid, which responds to how much load we're actually pushing through the chiller and how much it's had to load up. So that's what this bubbler tube is doing this entire time, is it's just letting this constant little stream of bubbles enter into this bowl assembly so that it has buoyancy and it's able to float up and down on the liquid refrigerant level. That is its entire goal and purpose. It's just that whole bowl is a pocket of vapor that is moving up and down just like that cup would. If you could do this experiment yourself. If you haven't seen this kind of thing before, just get a bucket or a bowl of water with an empty cup and make sure it's got air in it. Tip it upside down, put it on that water, and then just try to like push it down or something. Like, you can feel the resistance and you'll see that cup, spring back up to the top of the water level. Like, that whole process is how we're getting this valve to control. And then from there, it flashes off, meters down, low pressure refrigerant, or lower pressure at minimum, leaves the metering valve, and we have now controlled flow going into the next phase of the process. So that is a more complete explanation of at least my understanding of how Carrier is using a flask chamber and then using the float valve in order to meter this refrigerant through the rest of the machine. I don't know of anybody else using this particular design. Prior to this design, Carrier was using a ball valve, not a ball valve, a ball float. And I found some diagrams of it, and it looks like I haven't seen one of those in the field personally. I've only seen the style with the float valve like this, but seeing some diagrams of those ball valve, or the not the ball valve, the ball float style, they're pretty gnarly looking, at least from the diagrams that I could find of how like the mechanical armatures and stuff are set up. So anyway, I don't know if you'll see any of those nowadays, but at minimum you will come across these float valves at some point. So in terms of just explaining the float valve operation, that is the core principles of how they function. All right. By the way, that didn't work out too bad. I am curious to your feedback on trying to like use the manual like that. What I've been doing in the past is I'll like look that up on my phone, then try to scroll in and hold my phone up, and you try to look at my phone screen, or I've done it on a tablet as well. And in this particular case, I was like, well, I was thinking that maybe this would work better, right? And actually have the physical book printed. And I'm thinking about just getting a library of like books on a shelf here beside me that I can just kind of grab and pick from. And if a question comes up that's super specific, or I want to show a diagram, like I could do a diagram like I do with these, right? So this is one way I've done diagrams. I feel like this has worked fairly well as well, but I also think that, pulling it up in the manual and like actually looking at that, and at that point too, like sometimes we end up reading a bit if we're trying to investigate something specific. I don't know. I'm just kind of playing with it. Curious to hear your thoughts on how well you felt like that flowed. How you doing, everybody? It's great to see everybody. Yeah, Agon, I've got ideas. Yeah, the HVAC time textbook. Yeah, it's going to be a while. I'll tell you that. The amount of work it takes to build, especially what I need to build that the industry doesn't have right now, it's going to take some serious effort. But I got things. It's good to see everybody. How you doing, Tom? So go. That was you, Vladimir, right? That was your actual name. Maybe you don't want to say that on the stream. But how you doing, bud? I hope you had a good week this week. I see you there, Tom. I see Jonathan. We got a handful of questions here. I'm going to start working through them. And feel free to just continue adding to the chat. And keep in mind, as I'm going, if there's something that I don't explain in the question and you'd like me to spend a little more time on it, just something maybe I bring up that's just you haven't heard about that either, feel free to just continue adding those questions into the feed and I'll cover as much as I can get to. Do you like York chillers over Tranes? See, these are the kind of questions that get me in trouble. I actually am working on a tech letter. So if you don't know, I do actually have a tech letter I send out twice a week, so every Monday and Friday. And I have a question similar to this that I'm working on writing. So anyway, if you want to get in on that tech letter, just all you gotta do is email me, right? I don't have it. I'm working on getting a public way to enroll yourself into it instead of how it's currently being done. If you go sign up to my free course on at chilleracademy.com, you get automatically enrolled to the tech letter. That right now that's the way, that's how you can get into it automatically. Otherwise, you can just email me and I can add you to it manually. That's perfectly fine too. If you don't know, my email is hvactime@hvactimetx.com. I'll add that to the chat here, just so everybody has it. I do get a lot of emails in a day, so it is difficult to respond to all of them many times, but I do the best I can. Okay, so if you do want to email me for any reason, you got that there. All right, so do you like York chillers over Trane? At one time, it would have been a resounding yes. Now, there's some things that have kind of changed my position on this. One of the great things York had for when Trane went to their UC line of controls, which is what we have to use TU on, so it's the little white controllers instead of the classic, like what was it, stainless steel blocky things they had in there at one time, which I guess that was technically the UPC line. Then they went to the CH530. The CH530 control system was actually great by Trane. When they went to the UC system and then they started to gatekeep their TU software, that's when things fell apart with Trane for me. And I already had some issues prior to that where like Trane will limit how much they'll sell you. There's certain things they just won't let you buy because they only will allow their people to come do it. And I've heard people have found workarounds to this and they've gotten some of those supplies before, but to give an example, they're AFDs. If they have an AFD fail, one, they won't sell you the panel, right? So if you have a catastrophic failure where you just need to replace the AFD assembly, they won't sell it to you. They will only come do that themselves. Which to me, I'm just not about that kind of thing. So York for a while was a much better alternative because you could still access their panel. You could do all the service stuff you needed, and then like you could still order their drive assemblies, like all the parts, like you could just get everything you needed. You could be very self-sufficient. You didn't have to rely on York for everything. Now there were some minor things here and there, and fine. To give an example, to replace a BRAM on their air-cooled line, you ended up having to have York come out and program in the serial number, which I think is just stupid, personally. I kind of get it from their perspective, because if you get that serial number wrong, it can mess some things up on the machine. At the same time, though, like, just let us talk to somebody and be like, hey, bro, can you help me out here over the phone or something, right? That would have been a better direction. So anyway, though, York um, York will really York was much more helpful, if I can get my words out today, until they weren't. And then over the years, York, it became more and more tricky depending on what you wanted to buy. Like I had one scenario where York did not want to sell a drive assembly for a YK I was working on at one time. And I was going through the local distributor, but they were giving the distributor grief because they didn't want to sell it to the distributor to then sell it to us. Like that it hadn't really happened that much, but that was just kind of one of those weird ones. Like it wasn't even that big of a drive. It was a smaller drive assembly at that point. They still got really weird about it. I don't understand why, but their killer for me was when they implemented their access manager, which is version like 10.02 or 03, something like that, of their firmware. When they implemented that firmware and everything moved to Access Manager, to where now you have to have a subscription for every chiller you want to access, and you get a one-time code. The same thing that Carrier did with their panels, right? You have to, which Carrier doesn't charge you money for, by the way, but York does. So now you've got to pay a subscription for these serial numbers you have on your system, and then that's how you can get a temporary access code to do whatever it is. But then what makes it worse with York is they don't give you the full access that they used to. So at one time we could use the factory service code, which is 1380. That's what you could log into the panel with, and you could do whatever you needed to do. Like you could be fully sufficient. But then Access Manager took a lot of those features away. Not all of them. There's still a lot there. And especially, there's still a lot there. But they took a lot away. Like there's certain things we just absolutely cannot do anymore that we used to be able to as a third-party vendor specifically. And I just find that ridiculous. So at that point, York and Trane really become on the same boat. It really depends. So I don't have a preference anymore. At one time, I would have probably told you to, if you could go York, go York. At one time, I would have said that. And I was having a better experience working with the York side of things than I was trying to work with Trane's side of things. I had less friction. Just as a technician trying to do my job, I had less friction. But that changed. So now it just comes back to application and preference at the end, right? So they have their strengths and weaknesses. The York machines are very efficient for what they are, but they have a weakness where, in my experience, they don't handle high lifts as well as a Trane does. That's one of the struggles with a single stage high-speed impeller versus Trane using their multi-stage low-speed impellers, right? That's just some of the engineering trade-offs that you end up having there. So in short, it comes back to application and just what you're trying to accomplish, whether or not you want to go low pressure, high pressure, refrigerant system. That's going to change whether or not you want to. So the only way you can get a low pressure with York right now is going mag bearing, but you may not want a mag bearing for your particular site. You may prefer to have an oiled machine. So that comes back to what you need and your reliability. The mag bearings have been having a lot more issues compared to oiled machines. Right? That's just a fact. And like the mag bearing technology is not perfect. So that's where if you want a low pressure but you don't want mag bearing, you have to go Trane, right? So that's the kind of stuff you get into, and outside of that, I really don't care. I really don't care. And I do absolutely, Jared. Anytime we can, I love to just rip those stupid panels out of there for Trane and York and even Carrier, and putting in something like an MCS panel with their mags series, or they've actually. Well, I don't know that you can use the micro, but but for sure they're Magnum series. Like, go MCS all day, get rid of that factory trash and all their proprietary crap. Go in and actually make the machine what you need it to be yourself. I am 100% down for that. And I think it's a much better path nowadays, personally. And we see it a lot more and more. And I think it's something we're going to see more, where I just don't think a lot of customers are going to play the game. And they haven't. A lot of customers haven't played the game that the factory's been trying to pull and like really restrict down what you can do as the end consumer. And so that like MCS is perfectly positioned to dominate that side of the market. And they have, like they absolutely have been. If you've paid any attention, or if you're aware of MCS at all, like they're kicking butt. All right. Do you have any training coming up for the Carrier 19 series centrifugals? And the trainings I have, so there's two main trainings I have right now, Albert. So the first training is my certification course on chilleracademy.com. It's a self-paced course. Now, it's not specific on 19XR centrifugals, but what it does do is it teaches you all the same fundamentals that a 19XR does. So Carrier centrifugals use a similar design theology to a York centrifugal with a low and high speed. So they have a low speed motor with a high speed impeller, or impellers, depending on if it's multi-stage. So what my course does is it teaches you all the fundamentals, and it doesn't teach one specific model. I teach across many different models, and I pull a lot of different examples in and really show you this is how the industry does this from a fundamental scale as a whole, and then everything else kind of builds out. And something that York does, they take a little bit from Trane, and not York, I'm sorry, something Carrier does with their 19 series, they take a little bit from Trane and York on their design. And you see that in, when I say take away from, I'm not saying that they're literally just copying. Carrier has always done it their own way, so don't get me wrong. What I mean is, if you're familiar with York and if you're familiar with a Trane machine, there's concepts in both of those that get used in the 19 series. So the 19XR, whether single stage or two stage compressor, uses different aspects that you would also see in those other brands. And that comes back to the core fundamentals. So I would really suggest that if that's not something that, like, if you don't feel overly up to snuff or confident in. Now, the other side of that is I have a hands-on class coming up. The 19XR is a machine that we can discuss heavily in that class. So it is an in-person hands-on class that I'm doing in Houston. That will be, I'll have one class in March. I do still have some seats open. Quite a few have been booked, but I do still have some open. It'll be March 9th through 12th, or April 20th through 23rd of 2026. So it's a 4-day class in Houston, Texas. If you want to join me for that, send me an email, and I can talk things out with you. It's something I invoice for, so I don't have like a sign-up page online or anything you can go to. Once you're ready, I'll get with your company and get the billing info sorted out, send you an invoice. That's how we get you enrolled in the hands-on class. Those are the main things that I have right now that I could recommend. Outside of that, I don't have anything more specific on the 19 series, but if you have questions, feel free to add them, right? This is a great place that we can discuss this stuff. Let's see. Please, can I resolve failure issues on Trane CH530 air-cooled chiller? Yes, if you've got a, let's see, pull this up. Okay, with a CH530 control, what you'll need is the TU software by Trane. No, I'm sorry, not TU, TechView. You need TechView software by Trane. It is free. If you're wanting to look for it, you'll go to Trane's website, and it'll be like Trane Commercial specifically. You should be able to Google search Trane TechView software, or software download, Trane TechView download, something like that into a Google search. It should be one of the listings brought up, and it's like right underneath. Like it may present to you, hey, do you want to download TU? But somewhere in that same page, there's a TechView download as well. That's what you need with the 530 series, which I think the C-GAMs at minimum, their Trane air-cooled scrolls, are still using the 530. I don't think those have started to switch to UCs yet. I could be wrong there. The most recent ones I've seen still had the 530 series control panel, which meant TechView worked on it. TechView does not work on the other panels with the UC controller, but it does work on the 530 series. So if you're having a major failure, maybe you need to change a sensor out, you need to do some binding, whatever the case may be, get that TechView software. You'll need a 9-pin serial connector, so a DB9 to a USB. So you plug that in with your laptop and the software. You have to set your COM port. Okay, so there's a lot of technical steps here, but once your COM port is set, then you can connect to the machine. Then you can go into binding. There's a lot of technical steps in between there, and we would just have to kind of dive through each of those things. So just so you know. But absolutely, so the 530 does give you a lot of ability to still do things without having to pay Tranes. If you can even find somebody that will sell you a license, that's step one. That's not easy in and of itself. But then to pay for the license from there. All right. You still work in the field, or just teach now? So I teach. I do this. This is my professional gig. I was in the field for 12, 13 years, something like that. The majority of that was doing chiller and heavy commercial service. The first couple of years of my career, I was doing residential, got into light commercial, refrigeration. So that was the first 2 years, and then I had an opportunity to transition into the heavy side, and went straight from restaurant work into centrifugal work. Just the way things worked. That's not how most people's path goes, by the way. Usually, you'll make the transition with air-cooled scroll chillers, move into screw chillers. You'll really get fairly familiar with air-cooleds, then you'll move into water-cooleds, and eventually work your way up to centrifugals. Well, me on the other hand, and it wasn't by choice, it wasn't by design, it just worked out this way. I went straight from low temp work right into centrifugals, and then had to work my way back, which was challenging in and of itself. But I learned centrifugals before I learned screw compressors, to give you a clear picture there. So anyway, I just teach now. So I do these streams once a week. And then I spend a lot of my time building and developing Chiller Academy, answering questions in there, trying to make improvements to the system and just the overall education. And then when I'm not doing that, then I do some consulting. So I do have quite a few consulting contracts. I can't talk about most of them. They typically come with, or depending on the contract, some of them come with NDAs. Some of them are just companies reaching out and they're just needing help to figure out, hey, we've got this weird thing happening, don't really know what to do. So at that point, I guess that's one of the groups, that's of the things I do, that's what I'm working on. You're currently looking to get into the field, currently in residential, like commercial. Awesome, yeah. So exactly, you're right where I started, right? You're right where I started. It comes back to just find, I don't know what region you're in. Well, you just got to find the right people. Find the people who are working on it, right? If you can find those people, just get in with them as best you can. Just get in with them, and just remember, I recommend starting small. But there's a couple of big key unlocks for you that I think that have really helped me, and that's drawing conclusions between different types, or between what I learned in light commercial to heavy commercial and chillers. One of those key breakaways is we're processing water instead of air, right? So RTU or a walk-in cooler, we're processing air over the coil. Chiller, we're processing water. That's step number 1. Everything else stays the same. Heat transfer aspects are the same. All of that's the same. And then instead of CFM for cubic feet per minute, or if you're doing CLM, cubic liters per minute, whatever the metric version of that is, instead of CFM from a cubic feet per minute, we're now dealing with GPM, which is gallons per minute, and then convert that to whatever metric version that is if you need to. But that's the core difference, right? So if you can think about water flow the same way you already think about airflow, you've now got a core grasp of how the water flow works. Everything else stays basically the same. It's all the same principles. How you would troubleshoot low airflow, you're going to troubleshoot low water flow. Okay? One key thing to add that you typically don't learn with your current setup is approach. And by approach, I mean the difference between saturation temperature and leaving water temperature. That's a key one that we use in chillers that we don't really use elsewhere in the industry. It's not that it doesn't exist, we just don't use it. Those are numbers you can take, and they are useful if you just learn how to use them elsewhere. So yeah, those are some core things, right? If you can kind of get your head around that, you will accelerate your ability to grab the rest of the machine very rapidly. Just build that mental bridge between water and air. And once you do that, so much of the rest of the machine starts to make sense much faster. How does a York purge work? So Jonathan, my question would be, which purge? The newer purge or the older purge? That would be my question. If you're asking for the older purge, I don't know that any of us know how those things worked. Those things were horrendous. Their old oil-styled factory purges were just absolutely terrible. Now a lot of those on the old YTs got converted to the Ready Purge style, which was just a newer. It basically works a similar way the Tranes do. But I can tell you, like, if you're asking about the newer purge units on like the new mag bearing YZ, I can explain that if that's what you're asking. Just feel free to throw that down in the comments. I'll get to it. Yeah, okay, I see you there, Vladimir. Yeah, that's what I thought. Russian, but living in Uzbekistan. So what time is it right now in Uzbekistan? I guess I could look it up. It's always fun to me to just see how many different walks and everything everybody comes from. It has been a challenge of mine that I want to get better at, is learning more of the metric side, so that I can better communicate some of these things, because I work with so many of you guys that are outside of the US in general, and everybody uses metric, and I'm getting a little bit better at it. Like, I'm getting a better handle on how Celsius converts to Fahrenheit, and like I have improved because I've had to use it so much now, but I still have a long way to go. I do want to get genuinely proficient with metric units compared to what they call imperial, I think, is what everybody calls what we use here in the US is imperial units or English units, something like that. It's technically not English, I don't think, even though it gets so weird. Never mind. I'm just gonna stop there. Watching you from a plant. Yeah. How you doing, John? Or John Doe, since that may be your actual name, so I'm not gonna make fun of it. Yeah, not gonna do that. Because John Doe is like an anonymous alias, right? Anonymous. Hey, that's the word. Yeah, I was trying to use that word earlier, and then it just slips out. So that's not that there's nothing wrong with the name. I'm just saying, like, it. That's the the checkbook fake name, whatever. Anyway, first time here. Great stuff so far. Yeah, awesome, bud. Welcome. Let me get a drink of coffee. See you there, Sterling. Trane versus York. Let's go. Yeah. Why YouTube don't send notification? Good question, Vladimir. Why does YouTube do a lot of things? I don't know. I wish I did. My life would be very simple. It would be a lot simpler. It would be a lot simpler if YouTube made more sense than it does. I don't know. Instead of phone, use tablet. We keep the search phone. Okay, so Tom, you're saying that and I've got the tablet. I haven't used it in a while. This kind of thing I go back and forth on, right? Is the phone versus tablet. The tablet does make a lot of sense. Like, it really does. And being able to like zoom in. So that's one of the good things about tablet is, like, on this diagram, being able to zoom into it. Let's say we wanted to look at this one, right? So really being able to zoom in and like look at more intricate detail, which I could see with these cameras, getting it to explode to that scale. Like, if we look here, that might be kind of challenging. Maybe not. I don't know. Because I love the paper aspect, right? I don't know. I've gone far more analog as the world's gone digital. Like, I just love my paper at this point. I do a lot of my writing handwritten nowadays, and the AI has gotten really good at converting that into actual text. And I do that not because it's faster, just because I just enjoy it more. And so because I actually enjoy it, I do more of it, and I spend more time writing, right? I don't know. I could try that both ways, though. Maybe on a stream, I got to build the library to begin with, right? I just printed this one book off for today, because that's not one I had printed previously, because I have been doing that, right? So something I've been doing lately is I've been putting them in these little folders, and this is like my nightly reading kind of thing. After the kids go to bed, I'm just kind of sitting and chilling. Pull this out and refresh. I've been reading up on the CGAM just as a refresher. No specific reason. I haven't read that book in quite a long time, actually, and just decided it was time for a refresh, and so I've been doing that. Anyway, let's see. How do I resolve phase loss problem on Trane? So phase loss can be a tricky one because of what all that entails. Let's see. So with phase loss, I'm trying to remember. There's a couple of ways phase loss can get tripped or triggered as an alarm. One of them, obviously, is just we actually lose a phase, and if it depends on the control panel. If memory serves, if you get too far out of your tolerance, then it will. Specifically, it's monitoring for voltage, right? So if your voltage tolerance between legs becomes too great, it'll look at that as a phase loss as well. So what I've had issues with is the voltage pickups not actually reading voltage correctly to coming back into the control panel. I've had modules end up failing and not reading voltage correctly. I've had CT. Oh, that's the other one. CT rings, right? So if we have a CT ring that's either not reading correctly, having trouble, got a wiring issue, whatever. So that CT ring may trigger a phase loss because it's not seeing amperage correctly on one of the legs, and that high or low, or specifically low amperage on that particular leg triggers as a phase loss. Because that particular leg it's just below the threshold, right? Whatever the threshold is for that particular chiller. I say amperage is 10% variance, and voltage is 2% variance between legs. So once you get outside of that, even though you may not literally have a lost phase, You may have one particular phase that's dipping too low, especially at startup during the inrush part of it. When that happens, like that's very common to see the phase loss get triggered, and it's because just for whatever is happening, it could be an issue with the compressor, right? So I've had that where the compressor stator was having trouble, had a weak side of the winding. When the compressor went to turn on, it was causing a heavy drawdown, or it was something to that effect on the input side. It was causing, basically the input side would go unbalanced as soon as the compressor would try to engage, and it ended up being an issue with the stator itself. Change the compressor out, problem went away, right? So those can be really freaking tricky to troubleshoot. Let's see, what all have I ran into? So I've ran into the compressor issue, just reading the voltage or amperage correctly. What else have I ran into? I've had power feed issues from transformers happen. Transformer from the main electrical start to get weak, and that it wasn't keeping up with the chiller demand. I have had that happen. I've had to have the facility bring out their electrical providers before and actually adjust the transformers, because some of these they can do that. They can adjust the input feed transformers for the facility and like better tune that power feed coming in, and it kind of, I guess, adjust for some of those issues. So I've had to have that happen before. Let's see. What else have I had? I remember there was one issue. What was going on with that thing? There's one that comes to mind where, like, dadgum, did it cause problems. I remember it took us forever to figure it out. It was me and an apprentice on site. I don't remember offhand. Anyway, those would be some of the highlights I'm looking for when I walk up to that situation. Is obviously verify the voltage itself up front, and then if you can even get to the point of doing a startup on the compressor, which usually you can, like as long as you have power feeding in at all and that's working at all, then you can at least try to get to the point of a startup. If you can't even get that far, then it's just going to be a sensor issue, right? Whether it be in the control module itself, not reading the voltage input, or maybe there's a wiring issue. Maybe the wires aren't connecting to the proper phases they're needing to. Or if this is on a drive assembly, you may just have a bad drive or a sensor in the drive causing the problem. So if you can't even get to the point of turning the motor on before it happens, like that's where I'm focused on. And then once you get to where the motor does try to turn on and then it happens, then I'm getting deeper into the other side of things. Yeah. Let's see. On that topic, do you think there's a future for third-party contractors, or do you think the industry is going toward? I love this question. Look at you, Sterling. See, Sterling, typically you're stirring the pot, but today you got a great question. I'm just messing with you. Just messing with you. Give me 1 second. Okay. Do you think there is a future for third-party contractors, or do you think the industry is going towards locking everything up? I absolutely, firmly believe that third-party has a very real future. I do think we're going through a period of time where they are trying to lock down. I'm hoping that will change with time. So I could give the whole dialogue on why I think we're at where we're at, and it comes back to the factory corporate decisions, not the field level, not technician level stuff. Like, this is all factory corporate that's causing these issues for the third party. And so I've got a whole dialogue I could go into. I don't know that everybody wants to listen through that right now. But what I do see happening is, while Daikin's not perfect, Daikin has done a lot to really step in and fill in for what Trane, York, and Carrier are not doing. Like, you can still walk up and work on a Daikin machine. You can still service it. You can still do a lot of things with a Daikin machine that the other manufacturers aren't going to allow you to do. Now, you may still have some struggles getting a hold of literature. That's one of the current complaints I have with Daikin. They're similar to the others, where they're pretty tight on the literature. They really are. It's unfortunate. I think those are things we can work through long term. I think we can get around that stuff long term, but like, it's just something to be aware of. But from a control panel's perspective, from getting parts and support and all those things happening, Daikin is still doing a good job there. And that's where Daikin has really began to emerge as a major player on the stage, because people are becoming aware of what the others are doing, and then they either don't want it or they're tired of it. I've seen cases where they bought some of this machine or some of these machines and just got absolutely fed up with trying to deal with the factory side of it and completely abandoned that. And they either didn't buy again, they went Daikin, or they went Dunham Bush. Or what they are doing is they're putting in MCS panels. Like, that is a huge market right now, is retrofitting MCS. Like, that's one of the things that Compressor Solutions Group, CSG, that's one of the things they do, is they have a lot of MCS retrofits. A lot of the time, these are the reasons why. The customers are tired of trying to deal with the factory and getting parts, components, contractors being able to work on it, the whole bit. So they are just full on trash this control system. We're coming in with our own. We're seeing that. That has happened for a long time. At one time, before this whole proprietary race began, we typically didn't retrofit unless there was a hard failure. Like, I've done a number of retrofits throughout my career, and it was usually because it was an old unsupported panel that we couldn't, or it wasn't realistic to get parts for anymore. So that left us with just retrofit the controls. We put our own system in. On some systems, like, I've literally worked with a controls tech, and we've built out a Distech Tritium based system or controls ourselves, and wrote the logic and not the code, but wrote all the logic for it and things. Like, we've done that through just Tritium, and then MCS has really good prepackaged options where you can just get these templates that they've already designed for you. Like, they've already taken the time many times to go through and pre-design the loadout that you, or the firmware you need for that particular machine. You just slap it in. So that's what we used to do, but now I'm seeing it being done on relatively newer machines that aren't that old. They're just tired of it because of everything we've been discussing. So that's where I see, Daikin has really taken in, and Dunham Bush already runs MCS as an OEM control. So, especially, I'm very active in consulting with the data center market right now. There's a lot happening there, and Dunham Bush has done an amazing job of just owning that market right now. They're doing incredible, and they are MCS out the gate. That is their proprietary, or that's not proprietary. That is their control panel. That is the direction I think that we will continue to go, especially from a third-party perspective. I've gotten involved with ICE, right? So I am actively working with the ICE group, which, there we go, right? For everybody here in the U.S., They are it's a group of third-party contractors. We all specialize in chiller systems, and like this is our focus. How do we do this? How do we it is an organized effort to keep us in the game and compete against this proprietary movement that we're seeing happen. And we have representatives from York and these major manufacturers coming into this our conference, and like we're getting to have these conversations with them because we're still the ones that do a lot of their sales, right? We, the third party, are still heavily involved in their ability to sell equipment, which is something they're very interested in. And originally that was their core purpose. Their core purpose was not field service, it was machine sales. Somewhere along the way, they started to pivot that, and they became far more focused due to profits, in my opinion, right? They became far more focused on field service over machine sales, because at one time their service departments were cared more about just supporting the third party in the field, not trying to replace them. They've been on the we're just trying to replace you for a number of years now. They've had some success, but they've not had a lot of success, in my opinion. They've had some, but it is through the work that groups like ICE and standing up against that, taking these manufacturers to court in some cases. There's some things I can't talk about, but like these are things that groups like ICE are doing to fight against that and to keep our ability to take care of our customers possible, and to continue just fighting that fight and not letting them win just because they are who they are, right? And there's other players who aren't interested in playing those games, or at least they're not doing it right now, which makes them a much more obvious alternative. So I don't see third party ever going anywhere. I do not see it. I do see, at one time, no, I'm not going to make that analogy. Never mind. No, I'm not going to go there. I think there will be a correction at some point. I really do. I think that if we push this out far enough, hard enough, long enough, there will be a correction. The leadership will turn over. They will see that it's much easier to make their big money by working with us than working against us. They will see these manufacturers that are spending way more effort trying to work with us are taking their market because we're working with them. Just flat out. And I think that will eventually force their hand to pivot their strategy. And again, this is all high-level corporate decisions. This has nothing to do with the field or service side of it. Those guys are just doing their job. You factory guys, that's what you're focused on. You're just doing your job. You're not trying to hurt the rest of us. Those aren't your decisions you're having to make. Those are decisions being made by people who've never even seen the field a day in their life most of the time. Anyway. How you doing, Salem? Saeed. I'm still not sure if I'm saying your name right, but got to rip the locked out OEM controls. Yeah, we already got that. Is there a way to communicate with you without email? WhatsApp do you use for communications? So I don't, Vladimir, I don't have a number like that I openly give out for that purpose, right? My issue I would run into is I already get overloaded with emails, to be frank. I do my best to keep up with them, but I get very overloaded with emails. And I've really got to be careful with where I spend my time, and I've got to be very focused on building. Here's the thing. The academy is still young enough. When I say it's young enough, there is a immense amount to build. The vision of what it needs to be, right? Right now what you see is just a snip of what the industry actually needs to exist. It's a very small snip. I'll say it that way. And it's going to take a massive amount of mountain moving to get where I need to go. To actually, because that is like my goal is to build infrastructure, a legitimate system that the industry can use to get you guys where you need to be. That is my core function with what I'm doing. I want you to succeed. As you succeed, all of us succeed. Just as a whole, because we have better infrastructure support and we all can have more success in what we're doing. We can get paid better. We have better job quality. We can, as you start to build a reputation and really get the skills, you get to have a lot of flexibility to pick who you want to work for, because everybody wants you to work for them at that point if you do this correctly. Like, it just, so much of your world opens up once you get to that point in your career. But it takes this kind of stuff to get us there. It doesn't just happen just because. And the way that people used to do it doesn't work today. Like, the infrastructure that the industry used to have that worked really well with the apprentice and tech structures, they don't work anymore, because the guys who were training the apprentices in the field ain't around. They're gone. The vast majority of them have retired. And there ain't enough of us left to train everybody else that we need. So, I have to be very careful with how much and where I spend my time. So I can't have my number and stuff like that. It would just be too distracting, and it would add more. It would slow down my day. The people that I do need to communicate to make these things happen and to achieve these goals, like, it would really interfere with trying to communicate with them if I had stuff, openly public like that. So that's my reasoning as to why that doesn't exist. Oh, you're buffering like 1995. Well, keep in mind, some of the buffering... Oh, wait, no. I've had... The internet's actually been fairly decent on my end today. It's not been perfect, but it's been... The audio should be pretty clear. I'll catch up with you later, Tom. I told you last week I needed to follow up with you, and then life happens, and I didn't. But we do need to touch base, bud. I observe in York chillers, they have installed orifice type metering devices. Yes, I want to know, is this butterfly type modulating valve, or is it different? Why can't they simply use an EXV? This is an awesome question. And then to answer it, I've got pictures. Let me see if I can find them. I don't want to kill a bunch of time if I can't. I'll look really quickly, and if they're not where I think they are, I'll just move on. Alright, I'm gonna switch over to here real quick. Let me see if I can find what I'm wanting to find really quick. Let's go live. Right there. Okay, it's not in that one. Here, no. Yeah, just a few more seconds, and I'm just going to move on. I'll draw it either way. Yeah, I am not. Okay. Yeah, we're just going to move on. It's not where I thought it was. That's okay. All right. Just so we're all on the same page. I observe in York chillers they have installed orifice type metering device. I want to know, is this butterfly type modulating valve, or it's different? Why can't they simply use an EXV? It is a butterfly type of valve, in short. Now we call it a variable orifice valve. Okay, so we have a handful of valves in the industry. Why don't we start with just kind of discussing the different options that currently exist. So we have fixed orifice, or if is that right? Fixed orifice. I don't think there's that. I think orifice, something like that. Anyway, I did pass spelling at some point. I didn't do spelling bees. All right, we have fixed orifice. We have EXVs. You won't see them very often anymore, but TXVs do still exist, and at least in process chillers to some capacity. Almost everything's going to be EXV. Let's see, fixed orifice, EXV, TXV, and then we have we could call Carrier's float valve an option. All right, they're specific to Carrier, but then we have a variable orifice. Okay, so variable orifice is the one that York uses. Now, I do cover this in detail in my certification course at chilleracademy.com. So if you are enrolled in that, under the metering valves module, I have one in there on variable orifice valves. And I talk about all of these except for the float valve. I need to add that lesson in there. But if you want to find out more about this information and get into it there and have a more structured environment, just feel free to use that within the certification course. Now, people that use different types. So York was using fixed orifice in the beginning before they went to a variable orifice. And what this is literally just a perforated plate. Okay, so it's a big round disc with a bunch of engineered holes, right? Perforations that is going to create a pressure drop as it goes through there. Trane still uses these to this day, and then Carrier on their flask tank, we talked about earlier in the stream here, Carrier does use these in conjunction with their float valves as well, right? EXVs, most everybody uses to some capacity. Most everybody does. York is the only one that I can, at least from the top of my head, I can think of that is using a variable orifice. Now, it's not a normal butterfly valve. Okay, so when they call it a variable orifice, it is technically a orifice. So EXVs, so understand this, thermostatic expansion valve, TXV, geez. Thermostatic expansion valve is where this core came from. And then EXVs became the electronic version of this. That's kind of how these evolved from one to the other. So with a fixed orifice, a butterfly was a way to still have a single orifice, if you will, but we could adjust the flow of that orifice, where these cannot be adjusted. They're just set in a single position. The fixed orifice, it can actually be pivoted and change flow. So it is quite literally just we have our stem, and then we have our orifice inside, but there's actually a special cutout inside of there. And I wonder if I could find it on my phone here. I will look really fast. I think I saved it here at one time, because I really want to show it to you. Let me look really quick. I think this is, I have a lot of pictures that I need to add to my library that I haven't yet. I think that's some of them. As for Trane, real quick here, getting close, getting closer. I know they're just right here. I really want to show you what the inside of that orifice looks like. Come on. It's right here. No, not yet. I'm sorry. I know I'm getting hung up on this. I'm killing a bunch of time. I'm sorry. I just really felt like it wasn't that deep into my pictures, because I just saw them the other day. It's one of those things where, you know, once you start, like you get so far into it, you just feel like you kind of, you just want to. Come on, man. Okay, I gotta move on. This ain't working. Okay. It's a different kind of orifice that this can fully close but not actually isolate, because there's like this divot cut out in it, right? It's not full sealing like a normal butterfly would be. So normal butterflies, when they go to close, like they actually seal off and can isolate. These particular valves don't. They still allow some flow. And then we've just got a regular actuator that sits up top here and can drive this valve open and closed. And New York is using it based off of liquid level. Now, the second part of that question is, why not use an EXV instead of a variable orifice? That comes back to scalability. EXVs can only scale to so big before they just become completely impractical. That's why these float valves work so well. That's why fixed orifices work so well. That's why a variable orifice works so well. And that's why these machines that can really scale in size a lot use these types of valves, because EXVs, they only get so big before they just become impractical. That's also why you'll see a 300-ton RTHD, for example, will have a metering EXV block with multiple heads in it, and that's so that we can split the flow between the two heads to keep up without having this just ridiculously massive and expensive valve attached. Daikin does some of the same things, where as they start to get some of their larger machines, they have multiple EXV heads involved, right? So where it's they're splitting the capacity, and we did the same things with TXVs as well. Like, you even see this with RTUs. You can have really large RTUs, and the indoor coils, or the evaporator coils, will be split into multiple segments, and then we would have a valve dedicated to each segment, but they would all header off the same liquid and header back into the same suction. But we could split the load needed between multiple TXVs instead of having one just ridiculously massive valve. That's the issue we run into with EXVs. We can only just go so big. So with these styles of metering valves, though, or metering devices, these can scale to, I mean, all the way up to these, machines that are doing thousands of tons, 3, 4, 5,000 ton machines, these valves are capable of scaling to those sizes because this variable orifice, again, it just makes the orifice bigger in the end. And like it just gets bigger as it can go. Where the EXV, at some point, we end up with these just really gigantic valves that just don't fit. And they'd be so expensive and hard to work on, they just don't make sense. And so that's why by the time you get to those size of machines, like, you just don't see this being used. Now, some of it is York does make some smaller YKs, for example. Some of those smaller YKs could technically use a EXV block if they wanted to. There's a couple of things to that, though. One, they have to change their base design principle for the machine, because it's only going to be that small, tiny tonnage machine that's even going to use this. And when I say tiny tonnage, I don't think YKs go below 300 tons. It's somewhere around 300 or 400 tons. They could technically make a EXV, like a multi-head block, work at those tonnages, but then they'd have to like rewrite everything for that, versus they just make a smaller orifice. They just make this smaller, and then they don't have to change anything. They just make it smaller, and then it can scale to their size they need from there, and they keep a consistent design. Same thing with these Trane with a fixed orifice. They can keep it. The CVH, as an example, gets small enough that they could use this if they wanted to, but again, they have to change their design. They don't have anything in there for modulated metering valves or variable metering valves at all, because Trane's base programming just relies on the fixed orifice aspect. So yeah, that's a core fundamental, is just the design aspect of it. Not to mention, these are more expensive. So to not only do they have to change their design for those particular series, to where they have a special design just for the smaller tonnages, these are just more expensive to use compared to these. Now, here's the thing. Trane and York aren't trying to specialize in these smaller tonnage machines either. They're specialized at scale with large tonnage machines. Some of these other manufacturers, while they have larger tonnages, do much better at the smaller tonnages. That's one of the areas that they've specialized in and made really good machines. For those lines of machines, they can use this type of stuff because their ability to control at lower tonnages, you have more control with this than you do this, in my opinion. Your ability to turn down or derate or unload, however you want to say that, is higher with an EXV compared to these, and still be functional. But it comes back to, what is that manufacturer's focus and priority for that particular machine? That's why York, in my opinion, from my best assessment, does it the way that they do it. Hope everybody's having a great week. Really appreciate everybody being here, enjoying this time. I absolutely love these streams. Like, they're a huge fun part of my week, getting to sit and just talk and hang out and do what we do, right? Yeah. I will say, if you haven't checked it out yet, just go spend some time looking through Chiller Academy. I'd love to work with you there. Consider having your company sponsor you, right? I do company setups all the time. So if your manager ever has any questions, feel free to just ask them to reach out. We're getting a lot of companies involved now more than just the individuals, right? So all of you guys on an individual scale has made a lot of this possible and happen. In the beginning, companies, as usual, aren't really looking into this kind of thing. They just don't really know what to do with it. But you guys got in, you got engaged, you supported me early on, you kept this whole thing going, and now companies are seeing its legitimacy, and a lot of companies have gotten involved. What that means, though, is a lot of technicians are getting sponsored, where the company is able to come in and cover that tuition and that enrollment to be engaged and to get that training, which is really exciting. So I would just say, for any of those managers, if they have any questions, I'm more than happy to answer whatever they need. All right, so Jonathan said, new one. Oh, okay, so you were talking about the purge. All right, Jonathan, we're circling back to the purge. Got it. Yes. Okay. So let me erase this. Yeah, family show. Was I getting out of hand there, Sterling? I'm sorry. I do that sometimes. Yeah, I do that sometimes. Okay, Jonathan, let me come back up to your original question. And I'm going to post that. All right. Apologize. With the heater going in the house, the office gets pretty warm pretty quick with the door shut. So I'm just slowly roasting here. All right. How does the York purge work? Specifically, we're going to be discussing this from a newer purge perspective. So York is using what they would call like a ready purge design, right? It's very, very similar to what somebody like Trane or Daikin are also using on their low pressure machines nowadays. Now Trane, they have an earthwise, I think is what they refer to it as, for their purges. They are using things like a not reclaim, regen. That's what they call, the Trane calls it a regen, where they're capturing refrigerant. Anyway, there are specific things to each of these, but from a core fundamental perspective, I don't think York is using any of that stuff. I think they're just using a basic purge. I'd have to verify that, but ultimately it doesn't change kind of the core concept, because York is doing it differently than like Trane is, if you're familiar with Trane. So first, the purpose of the purge is to remove non-condensables. Let's just start with that. Non-condensables, so purge equals remove non-condense. Something I'm very specific with that I think we need to understand better. To have a purge, we have a low pressure machine, which means that our chiller operates in a vacuum, especially on the on the evaporator side. That also means that if we have a leak on the chiller, we are drawing in atmosphere from outside. Now, what is atmosphere comprised of? Nitrogen, water, and some other stuff, right? So nitrogen, we all are very familiar with. It's the same stuff we use to pressurize machines. It's a non-condensable. Water, on the other hand, is a condensable. So the moisture, the humidity that gets drawn into the machine will condense in the purge unit and will flow out. Okay, I'll discuss that here in a moment, but just understand the core function of a purge unit. We are processing non-condensables, which does not include the water or the moisture that gets drawn into the machine if there is a leak. But that is the whole purpose of a purge, is to process those non-condensables out so that the machine can still function when leaks happen. Not if leaks happen, but when they happen, the same way they would on a high pressure machine, which would be your 134A. Examples of low pressure would be your R11 or 123. Now, a purge is a dedicated little refrigeration unit. We've got a compressor. We've got a little condenser coil. And we've got the purge evap. This will have a metering device, MD, not that you can read that. And so compressor goes into the condenser feeds into the metering device, and then that's your basic refrigerant cycle. And this is completely independent of the chiller. Okay, this refrigerant does not ever mix or blend with the chiller's refrigerant, but they do interact here in the evaporator. So let's do a blow up of the evaporator itself. So in this evaporator, we have our refrigerant coil coming from our little purge unit system. So this would be your metering device feeding into the top. This would be your suction. Okay, coming back into the compressor. Now coming from the condenser. So over here we're going to have our condenser, the chiller condenser, and on a midpoint of that condenser we're going to come off and up and feed into the top of this tank. Okay, and I say a midpoint because typically purges are going to run while the machine is online. When the chiller is online, your non-condensables stack about midway in the chiller barrel. They don't stack at the top. They will stack at the top when the machine is off, but not when it is on. Okay, and that's a whole nother conversation we could dive into, but just understand where your non-condensables are and why these lines don't connect at the top of the machine. These are meant to run as the machine is running. These types of centrifugals are meant to run for days and weeks and months on end if they need to, right? Typically they don't. In comfort applications, they might. In industrial applications, right? They may run for months on end and never have to shut down. They don't need to shut down. So you have to keep that in mind, that all of these systems are made to where this machine doesn't need to turn off in order to process any of this refrigerant. Okay, so then we leave the bottom of the purge evaporator and come back to our condenser at that midpoint. So we're trying to reintroduce everything basically where it came out of. But it's coming in here as a vapor, and it's leaving as a liquid. It's part of the condensing process. So what's happening is, as the purge compressor runs, the little recip compressor typically that these will have, as it is running, it cools this evaporator coil. The vapors that are in here, the refrigerant and moisture vapors begin to condense, okay? Because this evaporator temperature gets lower than their saturation temperature, and they begin to condense down. All this is part of the high pressure circuit, by the way, okay? So all this is within the chiller's high pressure side of the system. So as they condense, we start to collect that liquid here at the bottom, and then that liquid drains out the liquid line, leaving the purge evaporator and into our chiller. Now down here there will be a purge dryer. This is meant to capture the moisture that is being condensed here. These dryers will very commonly have a moisture indicator or a sight glass of some kind somewhere. Not always, but very common. If it doesn't, I recommend adding one at some point, just so you can see the physical condition of that liquid leaving and have a moisture indicator to tell you how wet it is. If you see that sight glass is showing constantly wet, you need to be increasing your replacement cycle of that dryer, right? So if you see it's showing very wet, then you, like in that case, instead of changing this dryer annually, you might want to change it quarterly or semi-annually until you start to see a clean glass or a clean indicator. As it starts to show less moisture, then you can start going back to maybe an annual change, and that'd be perfectly fine. But that is how that's how we're gonna make that determination, is what does that sight glass say, which most of these systems will have included. Okay, so as our liquid and moisture collect down here, this is liquid refrigerant, so ref and moisture. Our non-condensables stack up here. Okay, so right here we're just talking about basic fundamentals of how these units work. I haven't got into York's specific way of doing it. Now, on the York side of this is where they get slightly different in how they implement what's called the pump out. So a pump out is when we sense that, okay, there's a lot of non-condensables up here, and it is time to remove those non-condensables. So we have a separate little special pump that sits up on the purge unit's frame, and we activate that pump. We open some solenoid valves, and that pump sucks that those non-condensables off the top of our chamber and rejects them outside, or it just gets them out of our system and puts them back where they don't matter. So that is called the pump out. Now, Trane does it one way, York does it different. Everybody has a slightly different version of this. How York is doing this specifically, they have a transducer. I don't want to clog up our... we'll put it over here. So they have a transducer monitoring pressure on this chamber. And then they're comparing that transducer to the condenser transducer. And essentially, when these pressures start to get too far apart, the differential, so basically this purge pressure transducer will show a higher pressure than the condenser pressure transducer. Now, I think it's somewhere like 2 to 3 psi or 2 to 3 degrees of saturation. I forget exactly which it is. I'd have to verify that in the book. But once we cross that threshold of where this just gets slightly higher than the chiller's condenser barrel pressure is, that is how York is determining, okay, now it's time to initiate a pump out cycle. So at that point, the purge unit and system still keeps running. That never shuts off, like just because we go into a pump out, and we don't isolate any valves coming to the chiller. What happens is we have a solenoid valve pulling off of the top of this tank going to our pump, and that solenoid valve opens, our pump out pump engages and starts drawing off these pressures, and it's able to once it initiates and it reaches over the start pump out threshold, it will continue that pump out cycle until these transducers show below the stop pump out threshold, which I don't remember exactly what it is. It's either that or it looks at a period of time. I think York has it on, it's either going to pump out for X amount of time, or it's going to show equalized pressures between the two. So once it does that, then it kicks out of pump out, and everything goes back to normal purge operation. So the purge will continue to condense that liquid, and this whole cycle is constantly happening. And this is true for any modern purge unit on the market right now. And they're just monitoring the transducer differential in order to determine, do we start to do a pump out or not. So we cross over threshold, pump out begins, everything else stays doing its thing. We finish pump out, the solenoid closes, pump out, pump turns off, and then it just keeps going until it registers that another pump out is needed. Now, we are monitoring for that pump out time, so that if we do exceed like if we do have too much pump out time, that will start to trigger alarms for excessive pump out. That means that we have major leak issues, or there's an issue with the purge unit. Think something is going wrong with the system that we're having to have excessive pump out. Maybe we've got a transducer or maybe we've got a transducer or sensor issue somewhere. Something like that could happen, causing a excessively high pump out state, more than just a leak. It may not actually be a leak issue. Could be other conditions. Maybe the refrigerant circuit got messed up on the purge unit and it's not able to, maybe it's not working correctly. Who knows? But that is the core, like that's what York is doing with this. They're using the same basic fundamental purge machine that everybody else is using right now, but they're just using pressure transducers in order to determine when a pump out is needed, where Trane as an alternative is monitoring the suction line pressure, suction line temperature. So if when this evaporator coil in this chamber needs a when the superheat, basically the suction line temperature drops below a certain threshold, which is like 28 degrees, the control system knows that, okay, this chamber is full, we need to do a pump out. So that's how Trane is doing it as a contrast, is they're monitoring the purge compressor suction temperature. That is what it's indicating it needs a pump out with, whereas York is doing the transducer, just to give a contrast as to how they're going about it. Okay, I see. So in Uzbekistan, it's 22:55. So it's what 10:55 is when you sent that. So that was, so you're 11 o'clock at night. So okay, so you're dang near 12 hours difference. Yeah, maybe not quite, but you're almost 12 hours difference between. So I'm in Central Time. So right now it's 12:53 my time. Yeah, interesting. That's a long way around the globe there, Bubba. Appreciate you staying up for it. Can you guys post some good YouTube channels that can watch to get more familiar? Absolutely. So, two that I consistently follow. I'll write them out here for you. Let's see. So two channels I can definitely recommend is what is it? Subcool HVAC. Make sure I got that name right. And I know the other one just recently changed his name. Subcool HVAC. Yeah, Subcool, that's right. So you can see it there. He has some other stuff that he works on, but overall, like he does quite a few chiller videos, right? There's an RTAE that he's working on. So this is somebody I'd really, like, I enjoy just kind of watching, right? He's got a little bit of a different way of approaching some of his troubleshooting and what he does than like how I do it. So that's always fun to just kind of see different approaches to similar or the same issues. But he's a good one. And then the other one is, I think he changed it to JJ Commercial. So Jason Johnson is the other one. JJ. I think he's changed it to JJ Commercial HVAC. Give me 1 second. Yeah, that's right. Yeah, so JJ Commercial HVAC. That would be the other one. JJ HVAC. Those are the two that I personally watch heavily. That did say subscribe, didn't it? So I had a weird thing recently where YouTube like canceled a bunch of my subscriptions, or like unsubscribed me for some reason. It's really weird. One of them was, I think, Jason's channel. They just unsubscribed me from Jason for some reason. I noticed, like, why haven't I seen something from Jason in a while? And I went to look in and realized, like, he wasn't in my feed at all. I had to go in and actually find him and resubscribe to it. It's like, that's super weird. Anyway, yeah, so in terms of those are two that I could definitely recommend. If you're interested in like some more basics, like fundamental type stuff, then AC Service Tech, Craig Migliaccio would be another one I would highly recommend. If you want to follow some of Ty Brenneman's stuff, Ty Brenneman is doing a lot of really good work on the fundamental side of things. Now, these guys are focused on like residential type stuff. These two guys here, Subcool and JJ, they're doing actual like heavy commercial work and chiller side work, right? So that's where, like, if that's what you're wanting to see. They're not like my channel per se. Now, they do have some stuff where they will sit and take some time and explain things. Don't get me wrong. They do more than just show you what they're working on. They will walk you through some stuff and explain it. But I'd say they do it slightly different than I did, right? So they're not the exact same style or anything like that, and they don't need to be. Yeah, check these guys out. Follow up. Tell me what you think. Gregory just dropped in. I'm in schooling. I have 2 classes left, but we only glazed the surface on chiller systems. Yep. Do you have any recommendations on a good textbook that goes into detail for chillers? No, Gregory. Sadly, I don't. Is that going to change in the future? Yes. Is a textbook going to exist one day? It will. Does it exist right now? No. Sadly. Even the books that I have come across are very outdated. And the classic, and I've got it right up there, the Refrigeration and Air Conditioning Technologies book, which is like the template book that everybody trains from and has for decades now. That book, like, it has a section in there on like chiller systems and stuff, and it's worth a read through. They have some stuff in there, but it's not a full blown like what we need to learn this side of it, right? If you're wanting to get into this side of the industry, you need far more than what that book has in it to really. It just, like you said, it just barely brushes over it, and it's not your instructor's fault. So here's one thing that's really important about going through trade school when you first get into the industry. It is critical while you're there to learn how the science of our industry works. Like, if that's one thing I could say about being in trade school, especially if you've got a halfway decent one, learn the science. A lot of guys get really hung up. They want to learn how to hook up gauges. They want to learn how to do this. They want to do all the hands-on stuff, and that stuff is fun. Don't get me wrong, and it's needed. You should practice those things. But some guys get so caught up and focused on the hands-on stuff that they don't take the science seriously. And then they struggle for the rest of their career severely. You will have decades to develop your hands-on, I'm telling you. Don't ignore it. Put time into it. You need to learn the basics. If you can't hook up a system at all, you're going to have a hard time getting a job. If you can't do a basic recovery, you're going to have a hard time getting a job. But I would spend the majority of your time, get your head around saturation, get your head around psychrometrics, get your head around these fundamental principles that our entire industry is built on. Everything starts at those and then goes up. Anyway, I'll get off my soapbox. I'm just saying, Textbook doesn't exist. There is one that will exist in the future. That's all I'll say for now. But enjoy school, man. This is an awesome industry. I haven't regretted it a day in my life. I absolutely love it. I don't get why York don't seem to bother with smaller tonnage like Trane and Carrier do. York does have smaller tonnage stuff, Sterling. It's just not as popular because it's more expensive. Trane and Carrier have done better selling that small stuff compared to York, but we could dive into that next time. I have a lot of thoughts there I could share as to why it feels that way. I see why chillers show liquid level set point not achieved and subcool. Okay, so I'm gonna save a few of these questions. I do need to wrap up here, so just give me 1 second. I'm gonna add these to the list while we're here. And if you have any final questions you want to get jumped into next time, if I'm trying to get into working chillers, what are some basic things I should know? Yeah, we'll cover all that in the next stream. As a European, I have to come in and say, yes, please do. Migliaccio. The G is silent. Interesting. I need to ask him if because I think all of us over here say it the wrong way, and I don't think he ever corrects us, and I don't know if he says it that way or not, to be honest. Migliaccio instead of Migliaccio. Migliaccio. I gotta practice that now. Thank you. That's actually really interesting. Italian. Got it. Okay. G is silent. I'm gonna text him and ask him about that. That's a fun factoid for today. Oh, we didn't do a fun fact. Oh, we'll count the Carrier 19XR thing as our fun fact and how the float valve works. It'll be good enough. It'll be fine. This will be our second fun fact. Migliaccio, G is silent. Now we got it. MTT, everybody. Make the time for your family, for your spouse, and for your kids. Hope you really enjoy your week. They really need you as well. It's a tough industry. There's nothing easy about our time or anything that we're doing. We have to make the time for them. I will see you guys later.